Hello all, welcome to the channel. Today we are going to solve another LeetCode problem which is basically based on the binary tree. So we are given a description, and then based on the description we have to create a binary tree and then finally return the root node, which is going to be our answer. Now there are certain conditions given in this problem statement. If you read the problem statement, so we are given this description. Description is nothing but kind of a small list or sub array where you have parent child information and then is left information. So if it is left is 1, that means its child is your left child of the parent, and if it is left is 0, then child is going to be the right child of the parent. And then based on this you go ahead and keep creating tree node. So for tree node you are given a node description here. So what is tree node looks like, class, and then based on this you go ahead and keep creating the tree, and then finally you return the root node. Now, one of the challenge in this problem is you don't know what is going to be your root node, so which node you have to return. So once you solve this, once you create a tree, you need to determine what you need to find out what is a root node is going to be, and then return. Once you return the root node, so that will be your answer, because the root nodes will be connected to all the subchilds, so automatically you will get this output. For example, in this one, so first node is 20, parent is 20, and then child is 15, and then is left basically 1. So basically, which means is 15 is the left child of 20, and then same way for 17 is the right child of 20. So let's look at quickly how we can solve this problem. So in order to solve this problem, we are going to use the hash map, our dictionary in Python. So we start traversing a tree and then we keep track of each node and which is available in a tree in hash in dictionary or not. So let's say I create a dictionary, and then first node I got 20. So 20 is not, so my dictionary is initially empty, so nothing is there, right? So nothing is there, so 20 is not available, so I'll add a value as a key as 20, and then value is a tree node of 20. And then I saw, okay, 15 is also not available in the tree, so then I'll also add 15 as a node in my dictionary. So this is going to be 15. Now it tells that, okay, 15 is basically a left child of 20 because it is given as 1. So I'll create node. So in this particular dictionary I'm going to say that, okay, left child of 20 is, which is, I'll pop up the 15, and then I'll assign here. Now for further I do a traversal, I see, okay, 20 is already there as part of my key, so I'm not going to add it. But 17 is not there, so I'm going to add 17 as a new tree node in my dictionary. So this is, I'll keep expanding my dictionary, and then it says that, okay, 17 is basically a right child of 20. So I know 20 is already there, so I'm going to pop out this element, and then in this value in the right node I will assign as that is 17, tree of 17. Same way I'll continue. Nice. Now you see 50 is not there, so I'll add 50, and okay, I see a 20 node is basically left child of 50, so I know 20 is already there, so I'll assign left child as t of 20. This is my left child. Now again I saw 50 coming up, so 50 is already there in tree, so I'm not going to add it, but 80 is not there, so I'm going to add tree node as 80. Now I see, okay, 80 is basically a right child, so based on the 0, so I'll assign as a right child of t of 80. Now next I see 80 is already there, 19 is not there, so I'm going to add 19, and then this is going to be 19th node, and then I see this is left child of 80, so left child is 80 is already there, so I'm going to assign this left child of 80 is basically 19. Now the entire traversal is complete, no, nothing more left here, so my tree also complete. So if I see here, so 50 is already there, then 50 left child is 20, and then you have 80, and then further if I do a traversal, I check on 20 I have left child as 15, and then right child as 17, and then on 80 I have left child as 19. Now my tree is ready basically, but I don't know which node to return here, right? Because I have all the nodes as a key and then corresponding trees information. So which one to return here? So what I'm going to do is I'm going to keep track of the child node. So I'll have a set basically which will keep track of my child node. So as soon as I'm traveling right here in the tree, I'm assigning left and right child. So I know these 15, 17, 20, 80 and 19, these are the child. I'll keep track of the child nodes. So I'll keep adding anything. And then from this tree, I'll try to determine which of the node is not present in a child node. So once I keep traveling, so I know child node will contain 20, 15, 17, 19, 18. All of them are present in my child set. But 50 is not present. So that means 50 is going to be my root tree. So I go to the hash key, I'll go to this particular dictionary and then I try to pop out 50th node, the value of the 50th node. So once I return this particular node, this is going to be my result. So it's quite simple. So let's look at the code here. So uh, so I'm going to create a tree. So this is my dictionary, and then in this dictionary I'll also keep track of the what are the children's that I see across the path, and then I start traversing the tree description that I have. So in this I have parent, child and is left. If parent is not present in the tree, which is true in the initial case, I'll add it and create a new tree node. If child is not there, then also I'll add it as a new node in the dictionary. And then I'll check whether it is a left child or right child. If it is a left child, left is 1, then for that particular parent, I'll assign the left as a child node. Otherwise, I'll assign to the right node. And then I'll update my children's dictionary. So in the children's dictionary, I'm going to keep the track of what are the child nodes. Once I have completed the entire traversal from this, I'm going to determine what is the node which is not present in the children's list. So if I traverse a tree and then I try to see if any of the node which is not present in the children's list, so that is going to be my result. So I'll take the parent, the key, which is basically I'll get 50, and then what is the corresponding value for this key. So that is basically your tree node here. This is a tree node. So once you return this, all the nodes are connected to this left and right child of the parent node, and that is your result. If you run it, it should work fine. It works fine, and then you can just go ahead and some works pretty well with 95%. It's 95%. Hope you like the video. Thank you for watching.